All right, Unit 7, Section 3. Let's take a look at our problems in our volume to volume notes. All right, I do want to say that this has to do with, these are gases. And one important number you need to remember, like I said, you can go back and read. I just really want to go through the problems for these videos. But 1 mole of any gas at standard temperature and pressure, which is what the abbreviation STP stands for. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere. But any mole, 1 mole of any gas is 22.4 liters. Okay, so that's an important number for you to remember. All right, so let's take a look at this one right here. How many moles of air are in a 2-liter bottle? Assume STP. All right, so let's look at, let me get my annotation tools up. Here we go. All right, so remember we said 1 mole of any gas at STP, standard temperature and pressure, is 22.4 liters. All right, so they said we have a 2-liter bottle. All right, so start with what you're given. We have 2 liters. And we said that there are 22.4 liters for each mole. All right, and they want to know how many moles we have. So again, 1 mole is equal to 22.4 liters. This way we can eliminate our liters and we're left with moles. So basically this is going to come out to 0.0. You get some long number like 8928, and it just keeps going and going and going. But we can just say that we have 0.09 moles. We'll just round it. Okay, so that's how you tackle that one. All right, let's take a look at our next one. Get my annotation tools back. There we go. All right, this one says rank the following based on volume from largest to smallest. Oh, wait, I guess I need to get the ranking up there. I don't know, are they items that we're going to be looking at? All right, so we have 1 mole of hydrogen gas. Remember, 1 mole is the, when you're looking at gases, 1 mole, what do we say, was equal to 22.4 liters. So we know that one right off the bat, 1 mole. All right, for xenon, it says you only have 0.75 moles. So let's take 0.75, multiply it by 22.4 liters to see how many liters we actually have in 0.75 moles. That should give you 16.8 liters. All right, for these to get a little more complicated because we don't know the number of moles, we are going to have to convert to moles. So I'm going to go over here so I don't get too messy on that side, and let's look at our molar mass. H2O. We have hydrogen, which has an atomic number of 1. We have 2 of those. That's 2 grams there. Now we have 1 oxygen, which is atomic mass of 16. 16 plus 2 is 18 grams per mole. All right, so let's figure out, we have 5 grams of H2O. Okay, right there. And we want to know how many moles that is. And we just said there's 18 grams per mole for water. All right, so that cancels out. You get 5 times 1 is 5, and then you have 18 on the bottom, so 5 divided by 18, you should end up with 6.22, I'm sorry, 0.28 moles. What am I doing? I'm skipping a step. Put that in a calculator, and you get 0.28 moles. Okay, so now that we know that 5 grams of water is equal to 0.28 moles, now we can multiply that by 22.4 liters and figure out what we have. That's 6.22 liters for that one. And our last one, we have 5 grams of CO2. So the molar mass of CO2, we have CO2. So that's going to be a C, which has an atomic mass of 12. And oxygen has an atomic mass of 16, but there's 2 of them. So that's 32. Add all these guys together, and it's 44 grams per mole. All right, let me get rid of my picture. Y'all don't need to see me. Okay. All right, so let's figure out how many moles are in 5 grams of CO2. So 5 grams of CO2 over 1. 1 mole is equal to, we just said 44 grams. Okay, the grams will cancel. Plug that into your calculator, and you get 0.11 moles. Okay, so now we know that there's 0.11 moles in 5 grams of CO2. So that is 0.11 times our 22.4 liters. And that gives us 2.55 liters. All right, so this wanted us to rank it from largest to smallest. Well, it looks like it's already largest to smallest. 22.4, 16.8, 6.22, 2.55. So there's your ranking. 1, 2, 3, 4. It's already in order. I didn't do that on purpose. Actually, I didn't make that question at all, so it's not mine to say if I did or didn't do. But there you go. There's your answers. So this is a handy dandy little thing to look at if you are trying to figure out which direction you need to go. So if they're given like the volume and you need to get to moles, it shows you what to do. If you need to go from moles to mass, mass to moles, and you know, so this is a nice little thing to kind of keep where you can get to it. All right, example number 3. How many moles are in 1.9 liters of carbonic acid at STP? Again, standard temperature and pressure. So we know we have 1.9 moles of our carbonic acid. And remember we said 1 mole of any gas is equal to 22.4 liters. All right, so 1 mole. No, sorry, I need to fix that. That should say liters, 1.9 liters. Okay, and this should say mole here because we're looking for moles. And we just said 1 mole is 22.4 liters. That way our liters are canceled out. And when we do the math, you are left with moles. And that should give you 0.085 moles of our H2CO3. Okay. Moving on. What is the mass of 9.3 liters of CO2 at 1 atmosphere and 0 degrees Celsius? That's STP. We said STP, standard temperature is 0 degrees Celsius, and the atmosphere is 1 atmosphere, or pressure is 1 atmosphere. So just kind of get used to seeing that. They might sometimes say at standard temperature and pressure, or they might say at STP. This is STP. Okay. So don't let that slip you up. All right. All right, for this one, like I said, we know we have 9.3 liters. So 9.3 liters. This is a two-parter too, because look what they want in the end. They want mass. All right, and we said 1 mole of any gas is 22.4 liters. Liters cancel out, and we are going to be left with 0.42 moles of CO2. All right, we're almost there. We have moles. Now we got to convert to mass. Okay, because they don't want moles, they want mass. All right, so what's our molar mass of CO2? Okay, carbon, atomic number, or I'm sorry, atomic mass is 12. Oxygen, atomic mass is 16, but we have 2 of them, so times 2 is equal to 32. So 44 grams per mole. All right, and we know we have a 0.42 moles of CO2. And 1 mole of CO2 is equal to 44 grams. Cancel out moles, and you are left with 18.5 grams of CO2. So that's the final answer for that one. Okay, and we can round that to 18 because of our 9.3 there, 2 significant figures. So if we're looking at sig figs. At this point, I'm just happy that you're getting these problems right. So if you don't get the sig figs correct, unless I ask specifically for sig figs, then, you know, you're not going to get, I'm not going to mark them wrong. All right, checks for understanding number 1. What volume of 35.9 grams of hydrogen gas are occupy at STP, so standard temperature and pressure. All right, so normally, guys, I told you could round your atomic masses. Like for hydrogen, we normally say it's just 1 instead of using 1.00, I think it's 9. But in this case, or 007, something like that. But in this case, they were very specific because when you try to work this problem rounding, you don't come quite to the answer that they have. You end up with like 402 or something, which I just gave the answer away. But anyway, so you got to find how many moles are in 35.9 grams. I'll show you what I mean. So 35.9 of hydrogen gas. So on your periodic table, technically it's 1.007 times 2 because you have 2 of them. So your molar mass is going to be 2.014 grams per mole for H2. All right, so that's what we're using. We know we have 35.9 grams of H2. Okay, that's grams. And we know 1 mole of H2 is equal to 2.014 grams. We can cancel out the grams. And when you do the 35.9 divided by the 2.014, you should get 17.83 moles. Okay, so that's our moles. And they want to know the volume. So this is where we go back to our 22.4 liters per mole. If you know you have 17.83 moles. Okay, and every mole has 22.4 liters, then you just multiply it. And you're going to end up with 399, I got 0.29. But you can see that is the answer. If you don't use this 007 and you just round it to 1, you end up with a number that's like 402 or something, which I guess if you kind of know what you're doing, you're like, okay, that's probably close enough. But that's why even just a fraction, like 007, can make a difference in chemistry. All right, number 2. Which volume will be occupied by a gas containing 6.02 times 10 to the 23rd atoms? This number should look familiar to you. This is Avogadro's number, which is 1 mole of anything has 6.02 times 10 to the 23rd. And what do we say? 1 mole of gas at STP is equal to 22.4 liters. So guess what your answer is? You have 1 mole of gas, and 1 mole is equal to 22.4 liters. All right, moving on. Number 3. All right, this one we got to do 4 calculations. The gas with the largest volume at STP is. All right, we got to figure the molar masses of each first. So we're just going to do this right here next to each one. I'm going to squeeze them in. Molar masses. All right, if you look at helium, and this is just, you know, these are easy because you're just looking at the periodic tables. They're all single elements. So I went ahead and carried it out to the specific, just in case, because that last one threw me a little bit. If you look up neon, it's 20.18 grams per mole. Again, these are just the atomic masses on the periodic table. Argon is 39.95 grams per mole. And then krypton, if you look at the atomic mass, is 83.80 grams per mole. So we have 10 grams of each one. So we got to convert each one of these to the number of moles, and then we've got to use the 22.4 liters to figure the volume. All right, so I'm going to try to do these right here. All right, so we know we have we have 10 grams. We got to start with the grams. So we know we have 10 grams of each one of these. So we're going to start with 10 grams on all of them. 10 grams. And we know 1 mole of helium is 4.003 grams. Grams cancel out. You put that into the calculator. You're going to end up with 2.5 moles of helium. All right, neon. Again, 10 grams. All of them are 10. But now we know 1 mole of neon is 20.18 grams. We cancel out our grams. And when we do the math, we find out that we have 0.5 moles of neon. Next one, again, 10 grams of all of these times 1 mole is equal to 39.95. You can almost see the pattern, so you probably don't have to continue doing this, because each time we go down, it gets a little smaller. But we're going to work through them all. 10 grams of krypton, 1 mole is equal to 83.80 grams. Grams cancel, and we end up with 0.12 moles of krypton. Now, we're not done because we got to figure out the volume. And remember, 22.4 liters is equal to 1 mole, okay, of gas. So we know our moles. So now we just multiply each one by 22.4 liters. And that will give you the volume, 56 liters for helium. 22.4, you're going to end up with 11.2 for neon times 22.4. Okay, it gives you, like I said, you can figure this out. You wouldn't have to keep going, but just for example purposes, 22.4 liters, and that's going to give you 2.7, and these are liters, by the way, for krypton. All right, and the question was, which has the largest volume? That's going to be your helium, because look, it's the largest out of the 4. A lot of math for that one, and again, if you're savvy with how to do this and you start seeing the pattern, you wouldn't have had to have worked through all of those. All right, number 4 asks, a balloon is filled with 3.8 liters of helium gas at STP. Approximately how many moles is this? All right, so we start with 3.8 liters. And we know that Every mole has got 22.4 liters. That way your liters cancel out. So really you're dividing what you have, the number of liters you have, by 22.4 to figure out how many moles that is, 0.17 when you put it in the calculator. So there's your answer. It's letter A. All right, number 5. What is the volume occupied by 51 grams of ammonia gas at STP? All right, well, we got to figure out how many moles that is. So the first thing you do, as always, is figure your molar mass. All right, so our molar mass of NH3, which is ammonia. N has an atomic mass of 14. Hydrogen has an atomic mass of 1. There's 3 of them. So you end up with 17 grams per mole. All right, so we know we have 51 grams of NH3. Okay, and we know 1 mole is equal to 17 grams. So we can cancel out the grams. And when you plug this into the calculator, you're going to find that you have 3 moles of NH3. They want to know the volume. Remember, each mole of gas has 22.4 liters, and we have 3 moles. That's just 3 times 22.4 liters, and you should end up with the answer of 67.2 liters. Your answer is letter H. All right, for number 6, you are looking at 3 balloons filled with 1 liter of gas. 1 balloon is filled with argon, and they're giving you the molar masses for each one. One's filled with carbon dioxide gas, and then with hydrogen gas. But remember, all gases, 1 mole is equal to 22.4, so they're pretty much comparable. It doesn't matter, you know, with these, the volume is going to be the same. It's always going to be multiplied by 22.4. So if you have 1 liter of each one, then they're all going to be equal. Okay, argon is going to equal to CO2 is going to equal to H2. Okay, so it doesn't matter what gas you have, the volume is always going to be per mole 22.4 liters. So even if you have just 1 liter, it's still going to be the same volume for the gases. All right, number 7. Given the reaction above, what volume of oxygen is needed to react with 100 milliliters of butane? So here is a multi-step problem, very multi-step. In fact, I wish I had this whole thing to write on. In fact, I might duplicate the screen. All right, guys, give me a second. I'm going to go out and I'm going to duplicate the slide. And we're going to get rid of, hopefully this will let me just delete it, which it's not going to. I just need the space to write, so. Okay. And then on this next page, I'm going to need, I don't know if I need all the space, but I'm going to do it anyway. Still won't let me just cut it out. That's weird. All right. So at least this will give me some space to write. All right. Although I still have that. All right, let me go back to full screen, making sure you can see it. Share. All right, so given the reaction above, we have like 5 steps. So first things first. First, I need to be able to write on the screen. All right, so first we need to convert because we are dealing with milliliters here, and remember 22.4 liters is the volume of any gas, or 1 mole. 1 mole of gas. All right, so it says we have 100 milliliters. like I said, I'm just going to convert that just to make it easier. We're working with liters just to show you. Y'all need practice with this anyway. So you have 1 liter is equal to 1,000 milliliters. Liters cancel, and you end up with 0.1 liters. All right, so that's what we're working with. So how many moles are in 0.1 liters? All right, so we have 0.1 liters. 1 mole of any gas is equal to 22.4 liters. So we want to know how many moles are just 0.1. And you're going to get this long decimal. Did I do that right? 0.0045. Yep. And like I said, we are using C4H10, which is butane. So that's how many moles we're working with. All right. Let's compare ratios now, because we are looking at the volume of oxygen and butane. Okay, so that is a 2 to 13 ratio. And you got 2 of the butane to every 13 oxygen, but we know we only have 0.0045 moles right here of the butane, and they want to know the volume of oxygen when we have that much. Okay, so this is our first step. Now figure out how many moles of oxygen we have. So that's 2x. Just do your cross multiplying. All right, what did I say? 2 times 0.058. Is that right? 13 times 0.0045. Okay. 0.058. And just solve for x. All right, and you should end up with 0.029 moles of O2. All right, we got to figure out how many grams are in that. So we have 0.029 moles of O2 times 1 mole of O2. And this is where your molar mass comes in, guys. And again, y'all, by now, y'all should know oxygen is 16 on the periodic table times 2. It's going to give you 32 grams per mole. So our moles cancel. And let's see, I'm trying to find where I was writing on my paper. Oh, wait. We don't need to do that. Back up. We don't need to figure that because we are, I'm sorry, guys. We don't need to do that because we already have moles. I don't know what I'm thinking. I've done so many math problems. We got our moles right here. Yay, that's where we can stop, except for the part where you have to figure out the volume. Again, scratch that. I'm so sorry. 0.029 moles of O2, and we know every mole of gas has got 22.4 liters. Okay, and this is going to give you 0.65 liters. All right, now you're like, what the crap? I don't see 0.065. That's because we're still in liters, and look what we have. We have milliliters. Well, you can probably tell right away that that's what you should have, but just so I can show you, liters, converting it back to 1 liter is equal to 1,000 milliliters. So 1,000 times 0.65 is going to give you 650 milliliters. Lots of conversions on that one. All right, clear that out. Let's move on to number 8. All right. The reaction above, still working with the same one. What volume of water can be captured? All right, so we are now looking at water from 22.4 liters of butane. So we're looking at butane and water. All right. Well, luckily, they made this a little easier on us. 22.4 liters, we know that's 1 mole. 1 mole of any gas is 22.4. So let's compare our ratios. So we have 2 for our C4H10 compared to our H2O. There is a 2 to 10. There's your 2 and your 10. But now we know that we have, remember this is 1 mole, because 22.4 liters of any gas is 1 mole. So that's how many liters. We know we have 1 mole of butane, and they want to know how much H2O we're getting out of it. So 2 over 10, 1 over x, that's 2x equals 10, and solve for x. And you should end up with 5 moles. So we got to convert this to the volume now, and we know we have 5 moles of H2O. And remember, this is a gas, so times, or vapor, I guess you could say, times 22.4 liters, because each mole of a gas is 22.4 liters. That's going to give you 112 liters. Okay, so your answer for that one is B. Okay, clearing that out. Probably should have done the same thing for these, but we'll see. I have to write, this one is a long one too. Okay, so what volume of oxygen, let me get my annotation tools up here, I'm just going to write all over the screen. So what volume of oxygen needed to react with, we're talking about these two right here, 50 milliliters of nitrogen. All right, so first thing we want to do is convert that 50 milliliters to liters. Okay, so you're going to end up with 0.05 liters of our nitrogen. And from there, how many moles is in 0.05 liters? Remember, go back to our 1 mole is equal to 22.4 liters. Okay, so you can't forget that. So we have 0.05 liters times, there's 22.4 liters in every mole. So if you do the math on that one, you're going to end up with 0.0022 moles.